Hello, good morning, everyone. This is Dr. Eric Bricker, and thank you for watching A Healthcare Z. Today's training topic is generative AI in healthcare. So, as always, if we can do a quick audio video check, that would be great. So, in the comments on either YouTube or LinkedIn, you can put in if you can see and hear me okay. So, if we could do that real quick, that would be great. And then also, over the course of the generative AI in healthcare presentation, if you have any questions or comments and would like to add those into the chat, then please do so, and I will answer them over the course of the presentation, or I will answer them at the end. Now, many of you know who I am, but for those of you who don't, I'm going to give a brief background about myself. And as I'm doing this, let me know, type in where you're viewing from. I love seeing where everybody is from. Lee already put in Marietta, Georgia. Thank you for that. So I'm Dr. Eric Bricker. I'm an internist. I originally was a hospital finance consultant before going to medical school. And then I went to the University of Illinois for medical school, and then Johns Hopkins in Baltimore for residency in internal medicine. Worked as a hospitalist physician with the Baylor Scott and White healthcare system here in the Dallas-Fort Worth area. I actually started a healthcare navigation firm called Compass Professional Health Services that helped people with all of the sort of administrative paperwork, things related to their healthcare, comparing cost and quality, navigation, et cetera, and grew that to 2,000 employer clients with over 1.8 million people that we supported. And we grew that, and we then subsequently sold that business to Alight Solutions in 2018. And I worked so much with employers and broker benefits consultants that I started creating these A Healthcare Z healthcare finance videos as a way to continue to educate folks about how the U.S. healthcare system works, or does it work. And I'm very fortunate to now be the medical director for Simple Pay Health as well, which is an alternative health plan. And so with that, let me go here and look at some of the places where we have people from. Hamburg, Germany. Thanks for staying up late. Washington, D.C., New Delhi, India, again, probably, I guess, the middle of the night for you. Thank you so much for tuning in. Scottsdale, Arizona, North Carolina, right here in Dallas, Amarillo. We love folks in West Texas. Kensington, Maryland, wonderful. Oklahoma City, we love our folks north of the Red River. Belmont, New York, Bangalore, thank you for joining from India and staying up late as well. Bengaluru, India as well. Thank you for joining. Indianapolis. I believe the Indy 500 just happened. Right here in Austin, Texas. Atlanta, Madison, Wisconsin, San Antonio. Wonderful. Sounds great. I really appreciate Baltimore, where I did my residency, Charm City, New York City. I hope your air is cleaning up. Houston, Seattle. Wonderful. Listen, and thank you so much for joining today. Now, let's go to the source of today's information. So let me blow this up bigger so that you can see it. So Google has made a fantastic generative AI course available online for free. So here's the URL for it, cloudskillboost.google journeys 118. I'll make the slides available if you email me, but just know that there's a fantastic course. I would highly encourage you, if you're interested in learning more, they've got all these different modules that you can go through with videos, and there's a whole bunch of reading, and there you can even take a test at the end. So introduction to generative AI, introduction to large language modules, introduction to image generation. So a lot of this information today is coming from this wonderful training that Google provides. I have no connection to Google other than the fact that I post stuff on YouTube. All right, so now generative AI, what is this? So there's so much terminology that it's very important for us to just understand at a basic level what these terms mean. So generative AI is artificial intelligence that produces content. That's the key word. Generative AI is artificial intelligence that produces content. That content can be text, it can be audio, it can be imagery, in other words, pictures, it can be video, And so, as many of you are well aware of, like Chat GPT is an example of generative AI because you type in a prompt and it gives you text back, right? So now now of course AI needs to be put in or generative AI needs to be put in a larger context to just overall AI, right? Which is a computer system that trains from input data that can learn without explicit programming. So that's super important. It's software that can learn itself without having to be programmed. So the example that Google uses is for like a cat. Like historically, you had to program in, if you wanted the software to identify a cat, it would be like, okay, it's got 4 legs, it's got a tail, it's got pointy ears, it's got whiskers. Whereas with AI, you don't need to do that. You just show the software pictures of cats, and the software learns without being explicitly programmed. The software learns what a cat is. Now, another term that you will hear is deep learning, which again is sort of a subset of AI that allows for more complex learning. And deep learning involves neural networks. That's another term that we're going to get into in more detail, but that's really the brains. The brains of the AI is the neural network. And literally, that neural network is like software code that's written out, but it's software code that essentially acts like a brain. Now, because ChatGPT is all the rage, we need to specifically talk about ChatGPT. Now, GPT are not just 3 random letters at the end. They have specific meaning. They're an acronym, right? So now you know that the G in GPT stands for generative because ChatGPT is generative AI. It produces content. In the case of ChatGPT, it produces text. You type in a prompt and it gives you a text response. Now, the P stands for pre-trained. And the T stands for transformer. And pre-training and the transformer are super important. So we're going to go into a little detail about what those are. So pre-training is just the computer science term that they use for learning. So just like human intelligence, we have to learn. I mean, we're not born intelligent. We have to learn. Likewise, the artificial intelligence, it has to learn. And that is the process of pre-training. Now, ChatGPT itself is a chatbot that is based on the GPT-3 large language model. So, and we're going to get into large language models in a few slides. But the point is that ChatGPT itself is the chat bot that is acting on top of the overall GPT-3, and there's even GPT-4 generative AI. Now, the GPT-3 generative AI was pre-trained on 45 terabytes of data. And, you know, if you're a computer science nerd, you're like, oh my goodness, 45 terabytes of data. That's tons. But like for most people, we're like, that doesn't mean anything to me. What in the world is 45 terabytes? Okay, 45 terabytes is all the text on the entire internet. So in English, in Swahili, in French, in Japanese, you name it, all the text on all of the internet in the world is 45 terabytes. So they basically took the entire internet and they trained this generative AI on the entire internet. Now, there's other chat bots as well. So Google's chat bot is called Bard. Now the transformer. And the transformer is a huge deal as well because the transformer is a neural network architecture. So you heard me use the term deep learning before. So it's the transformer that actually allows for the deep learning. And the transformer has sort of several features about it. Okay, so one, and this is where a lot of the development in AI has really happened in the last handful of years, is they've really created these sophisticated transformers. Like the functionality of a transformer today is like light years different than it was just a few years ago. So one, it has this thing called positional encoding, which in language, apparently, and I'm not a linguist, but apparently in language, like the word order is super important. So it's not just the words, but like if there's a sentence like Sarah finds trouble, that's very different than the sentence, trouble finds Sarah, right? And so that's the example that the Google training uses. So the positional encoding allows the software to understand how the positions of the words in the sentence are very important for interpreting their meaning. Then there's another concept called attention, which is similar, meaning that the AI actually understands sentences, which, I mean, that's really how we read, right? We don't really read like one letter at a time and one word at a time. We kind of string it all together in a sentence because the sentence gives it context. And that gets us to self-attention, which is sort of a subset of attention, which is super important, again, in the functionality of this transformer, because what it does is it gives context. Like, so now and it understands synonyms. So now you don't have to train, you don't have to explicitly code the computer to say that, look, a software engineer and a programmer and a software developer, that those are all synonyms. Like, the software can figure that out from the context of the sentences. You just give it the 45 terabytes of data and they're like, oh, yeah, these words are synonyms. They mean the same thing. Likewise, it can look at, the languages are super complicated because you have the same word that has totally different meanings, like bear, right? Obviously, you've got the big, grizzly animal, but then you also have bear as into like bear weight. And so it's like, okay, the bear is chasing me, or the Golden Gate Bridge can bear, 2 million tons. And so like the AI is like the Golden Gate bear. Okay, so like when they talk about the Golden Gate Bridge, we're not talking about like animals, we're talking about bearing weight, right? And so that is self-attention. And apparently that was super hard to accomplish. So that is a very recent development within the last handful of years to be able to do that. So now you know what the GPT in Chat GPT stands for. Now, the prompt is what the person inputs. So I'm sure many of you have used Chat GPT. I've used it myself as well. So that's the task that you put in. And there's different outputs that you can then get as a result of the prompt. So you can do text to text. In other words, you type in text with Chat GPT, and then it gives you an answer back. But then there's also text to image, where you can just type in the description of an image, and the generative AI will create an image based upon your text, a totally unique image. And there's text to video. You can literally just type a text like describing what type of video you want, and the AI will produce that video for you. And then there is text to task. So sometimes you may be familiar with a term called an AI agent. I certainly see these AI agents described all over Twitter. And so here, you can actually type in a task for the AI to accomplish. So you can literally type into the AI, because like, can you just create for me a website? I mean, your prompt has to be more specific than that. There's actually a science to writing good prompts. But like, you can just be like, hey, make a website for me. Or you can actually you can be like, could you just type create this software in Python or C++ or what have you, and it will actually write software for you. It will debug software for you. And so AI has actually just within a very short amount of time has been able to dramatically improve the efficiency of software developers. Like, literally, they're able to generate code like 6 times faster than they used to, just within the last handful of months or years, because of what generative AI is capable of accomplishing, or just creating queries. So so many of you are familiar with SQL, and so instead of actually having to use like the SQL language to query a database, you could be like, hey, could you just find this for me in the database, and it'll be able to do that. So here is an example. Here, I'll blow this up here real quick. So here's an example of text to image. So the prompt of Captain American, look, they didn't even write America. They wrote Captain American throwing a snowball in the style of Rembrandt. And so this is what AI produced. Now note that, the article that I pulled this from, now note that it's not really in the style of Rembrandt. I'm not really familiar with what Rembrandt's style was, but the point of the article was that, this actually was not necessarily in Rembrandt's style, but you were able to type in something specific like Captain America throwing a snowball, and look, it even put in like the background and like an overall snowstorm. So it even put in context around it. And it obviously had put in the shading, et cetera, et cetera. So there's an example of text to image generative AI. Now, so in summary, the transformer, which is like, so GPT, it's like the letters are actually kind of backwards, right? So really it should be chat GP or TPG. It should be TPG, because you start with the transformer, because that's the brain, that's the neural network. And then just like the brain of a newborn or of a baby, then that brain needs to be trained. And so that's what the pre-training is. That's what the learning is. And then you give the AI, which has the neural network and has gone through the learning, you give it a prompt, which is your question or your command. And then it is generative in that it creates an output in the form of text or image or video. It creates content. It creates content. So there you go, in summary. Now, another term that you'll hear is a large language model, or an LLM. And this is where LLMs can be thought of as so it's a subset of deep learning. And so Chat GPT and GPT-3 actually are large language models. So like Bard from Google is a large language model because it's dealing with language. Now, to a certain extent, if you do text to video or text to or image, like that's not as much a large language model, because it's not giving you out the language as the output. It's giving you a picture as an output. Now, so just know that when it talks about large language models, it's specifically talking about generative AI that is inputting language and then outputting language, words, if you will. Okay, sentences. Now, another term that you might see is PaLM, which is an acronym, of course, because everything has to have acronyms, which is Pathways Language Model from Google. Now, the reason I'm bringing this up is because PaLM has 540 billion parameters. And of course, everything in computer science, again, it has to have a term. And so all a parameter is a skill. And so that skill could be like writing a poem. That skill could be like translating from one of the examples they use is from English to French. So it's got five, and so you can, if you think about like a language skill, and if you can't speak French, then like you don't have that language skill, right? So if you broke up language into sort of subsets of skills, then PaLM has 540 different language skills that it's able to accomplish. So it has incredibly broad depth of like linguistically what it's able to accomplish. Now, there are three broad types of large language models. So one is, and we see this all the time. We've seen it all the time for a long time, actually, multiple years, which is generic LLMs, which predict the next word. So like when you're typing into a Word document or into an email, or into a search box in Google, like you'll see, like you start typing something in and you'll see like words appear after that, right? So that's the generic LLM filling in like, oh, when you type in peanut butter, a lot of times the next word that comes is jelly, okay? Now, the next one is instruction tuned, which can summarize text. And we're going to get into the healthcare applications in a little bit. Or it could like literally just generate a poem in a specific style. Give me a poem in the style of Robert Frost. Now, next is then dialogue tuned, which is where literally you can have a dialogue with Chat GPT or with Bard. So these are subtypes of large language models. So let's spend the rest of this conversation talking about healthcare applications for AI. And I wanted to focus on applications that are literally being done like right now or starting to be done right now. I mean, you could probably think of all sorts of pie in the sky things that you can do. So this is not meant to be an exhaustive list, but these are things that are being done right now that, in my opinion, are incredibly helpful in healthcare. So one is documentation. Okay. So there is gobs and gobs of documentation that healthcare professionals have to do in the doctor's office, in the hospital, you name it. So the doctors, the occupational therapist, the respiratory therapist, name it. It's like you just spend so much time doing documentation. It's like unreal. So with that, 62% of doctors' time is spent with the electronic medical record, not with the patient. Okay. So there actually is today a way for the generative AI. So, like, you've got the note, right? The note has to communicate, it's a legal record. It has to communicate to other healthcare professionals or other doctors, like what's actually transpired during the office visit. It can be shared with the patient so that the patient can see. It's used for billing purposes to justify the billing that's performed. Now, today, like literally, we can pair ambient listening devices. So like I, Dr. Bricker, can have a visit with Joe and Jane, and that you can have just a microphone, sort of like an Amazon Echo, in the room, and it can just like listen to the conversation. And it has voice recognition and natural language processing. So it knows that like my voice is the doctor's voice and that the patient's voice is the patient. And then it can use generative AI that has learned how to create a note in the style and the format that physicians create notes. It has to have like it has to have a chief complaint. It has to have a history. It has different sections: chief complaint, history of present illness, past medical history, family history, social history, etc. And it can just listen to the office visit, and it can create the note. So you don't have to spend all this time writing the note. How incredibly helpful is that? That is like the coolest thing ever. Now, this is done today. Deep Scribe is a company that literally does this today. They're doing it at Stanford and at the Texas Medical Center down in Houston. Now, I have no connection with Deep Scribe, but it literally saves 3 hours a day, and it only costs 1/6 the cost of a human scribe. I mean, there are some physicians that use scribes, like literally a person. All they do is come with their little laptop and they just sit there and type the note so that the doctor doesn't have to do that. And so you can save 3 hours a day for a doctor. I mean, that is unreal. Okay, next up, prior authorizations. This is one of the first things that came out when ChatGPT came out, is that a doctor in Florida who's a rheumatologist said, what if I put in a prompt of write a letter to United Healthcare asking them to approve an echocardiogram on a patient with systemic sclerosis, which is a rheumatic disease that causes your skin and your soft tissues to harden, and make reference to supporting scientific literature and list the appropriate articles. And guess what? It did it in like a second. So doctors today have to do this by hand. They've got to write a letter: Dear United Healthcare, I would like to have an echocardiogram for John or Jane Doe. They've got systemic sclerosis. This is why I want it to be done. Here's why echocardiograms are clinically justified. Here's some references. I mean, it takes a ton of time. And he just said, hey, could you do this for me? And then, of course, everything in healthcare has to be done by fax. So we take this amazing new technology and then we have to transmit it to the health insurance company via fax machine. But the point is that it can do it. And in fact, Doximity has a beta version of this that they are using right now. And again, I have no connection to Doximity. Now, it's important to note that there are some limitations here. So like ChatGPT is not actively connected to the internet. In fact, ChatGPT was pre-trained on the internet pre-2021. So there's a lot of like standards of care and a lot of things in the medical literature and a lot of things that can be justified for prior authorization where information as of pre-2020-21 is totally okay. But just note that if there are like newer studies that come out or newer articles or what have you, if it's from 2021 or later, it's not going to show up because ChatGPT was not trained on that. Now, the rheumatologist in Florida also said, look, when you see those references, you also need to double check them as well. So that there was actually a case of an attorney that used ChatGPT, and apparently the AI actually even made up the sources. It made up the cases. These cases did not exist, so certainly it's not perfect. So you're going to want to, but when he read the clinical justification for like why it should be done, he's like, oh, that's totally right. Now, another thing that AI can be used for is to search and this is a personal favorite of mine, is to search and plan documents. So so a lot of people here work in health and like the plan documents. I mean, it's obviously all in PDFs these days, but back when they used to print them out, I mean, they're like this thick. And then also, and that describes like what your insurance covers and what it doesn't cover and how it covers it. Like what's your deductible, what's your co-insurance, like how does it cover durable medical equipment? And it's got gobs and gobs of fine print in there. Now, there's also medical policy, which is even more layers of fine print, which is, hey, your health insurance plan will pay for this medical procedure in this situation, but it won't pay for the same medical procedure in a different situation. And I have a whole nother training session on medical policy and its source of denials. And it's incredibly long and complicated. Me as a physician, I have a super hard time understanding this. So like your typical like lay person or plan member, they would have no clue how to read and interpret this. Plus you'd have to go through these pages and pages and pages that are not easily searchable to find the information that you need. But you can have AI. You can just ask AI a question about a document and it'll go through the document and it'll answer that question for you. And there is a software tool that's called Unriddle AI that reads PDFs, and you can just type in queries or you can just ask it to summarize it for you. And you can use it for free for a document up to 120 pages. And you can do 4 queries a month for free. Now, if you want to upgrade it, you can do up to 4,000 page documents, and you can do 250 queries a month for $50 a month. Again, I have no connection to Unriddle AI, but if you were working as let's say an account manager as a brokerage firm, and let's say your client is like, hey, or I've got, or even if you work in benefits in HR, and you've got an employee that's like, hey, can I do, my health insurance is saying it doesn't cover this or whatever. And you're like, I don't even know if our plan does or does not cover that. And instead of you having to rifle through the plan documents of the medical policy, you could just use Unriddle AI to be like, hey, for our Blue Cross United Cigna Aetna policy, does it cover, echocardiograms for 17-year-olds who had one episode of palpitations while playing soccer? And like, it'll shoot out an answer for you. Now, interestingly, it can also search medical records. And so there's actually a partnership between the Mayo Clinic and Google that was just announced on June 7th of this year, 2023, where Mayo is going to take, de-identified patient data, and they're going to allow Google's generative AI to then look through those medical records. And that would be extremely helpful as well, because doctors and, clinicians, we have to do we call it the slang term for it is a chart biopsy, where, you've got these complex patients that have gobs of previous visits, or their hospital stay might already be a month long, and you're just coming on to be consulted as the cardiologist or what have you. And you're like, oh man, I got to spend all this time looking through their medical record. Whereas literally you could just use the AI to be like, hey, could you summarize their stay for me? Or could you tell me specifically what happened with this particular, like I know the guy had a cardiac cath, but can you just find that in there and let me know what happened in the cardiac cath? So the effectiveness and the accuracy of the chart biopsy, of actually looking through those charts, could be tremendously better, especially in the ER, right? Because in the ER, you don't have time to look through all this stuff, right? So the patients would come into the ER and the ER doctor would look at their medical record that was already in the system. And they're like, oh man, I can't keep this straight. There's no way I can figure all this out. It's an emergency. Whereas they could actually just use the AI to like very quickly answer like what they would need to know from the huge medical record. I mean, that would be unbelievable. Now, so what are some take-home points? All right. So in summary, AI is the software that learns. Generative AI creates content. Large language models, LLMs, understand and create words. And the process of generative AI involves a transformer plus the training plus the prompt that then gives you the output. And specifically, generative AI can create healthcare documentation, which can save time, improve accuracy, make the communication better, and lessen burnout. I mean, as far as like, I mean, it's not going to cure it 100%, but as far as making huge leaps in addressing physician and nurse burnout, this is huge. Okay, now you can also use generative AI to search and summarize convoluted documents. And health insurance documents are convoluted documents. If you work in benefits consulting, insurance brokerage, I would love to use that. That would be super helpful. So with that, there's the sources. We're approaching our time. In fact, we're 1 minute over. So look, if you would like to connect with me on LinkedIn, please do so. If you'd like to follow my A Healthcare Z or subscribe to my A Healthcare Z YouTube channel, please do so. If you would like a copy of today's slides, please email me at ericb@ahealthcarez.com. I also have a email video newsletter. If you just go to ahealthcarez.com, you can sign up for my email newsletter. We've got over 3,700 people. You've put a lot of great questions in here. I will answer them in writing afterwards because we're at the end of our presentation. So with that, thank you so much for attending and have a great Friday and a great weekend. Bye, everybody.